I thought every equation had an answer, had a solution, but today we're going to look at equations that have sometimes more than one or even no solution at all.
Let's explore equations, and we're going to actually explore equations that may not always have one solution, similar to what we've already had. In this expression, we have 4 boxes set equal to 2 boxes plus 6. And we're going to assume that all the boxes have the same value. So I'm going to express the expression on the left as 4x and on the right as 2x plus 6. And we're going to verify, is there actually only one true solution to this? And we're going to put all our variables on one side. So I'm just going to decide to put them to the left, which means creating a 0 pair here. Now 2x is equal to 6, a simple one-step equation. And I come up with one solution, meaning x is equal to 3. There's only one solution here. And if I were to actually plug this back in, and I'll go into looking at my visual, 4x, or 4 times 3, would have the same value as 2x plus 6, or 2 times 3 plus 6. If you were to work them out, you would have 12 on both sides. So this tells me something. It says I only have one answer here. It went to x equals just 3. What if I were to put any other number in? Like, let's say 4. If you were to substitute 4 in there, would you still get an equation? Let's see. So I'm going to just erase this out and try this. What if this was 4? Well, I would get 16 as the expression on the left, and 8 plus 6, 14 on the right. This is not true. So 3 is what satisfies this expression. You can try it with any other, but algebraically, when we work it out, we only get one value for x, meaning 3. So hit pause so you can jot this into your notes. Awesome. And let's try 2 other situations where we may not have one simple solution. Here's one, and I'm going to be really explicit and tell you from the beginning, this one is not true. This is not a true solution. Looking at it, we have x plus 10 as equal to x plus 20. Just knowing, and again, this is a thought experiment, if you remove the x from both sides, like if you took x away from both sides, could that be a true statement? Like, think about this for a second. If we were to, let's say I wanted to put the x on one side of the equation, so I'm going to move it to the left. Unfortunately, it cancels out, and I got 10 is equal to 20. That is not a valid statement. It is not true. So there is no solution to this. And this makes sense because being that I only have one x on both sides, no matter what I put in there, as long as I'm adding it to 10 and adding it to 20, there's no way it would be equal. So even if x was 5, 15 plus 20, not equal. If it was 10, 20 plus 30, not equal. There is no valid solution. This is a case where our equation does not work. There is no solution. And when you work this type of problem out, you'll find that your x's do not work. Now, what if you said, well, miss, what if I moved my numbers instead? Okay, let's try it. X plus 10 is equal to x plus 20. If you subtracted 10 from both sides, x is equal to x plus 10. Okay, now what happens? Look at this. So now I have nothing on one side, and I just get 0 is equal to 10. That cannot be true. 0 cannot be equal to 10. Again, this is not a valid solution. So if algebraically you work through the problem and you find that there is no answer that is a true equation, then know that there is no solution to that equation. Hit pause and let's add this to your notes. And let's look at one more scenario. In this case, we're going to talk about infinite solutions. And I'm just going to express this as x plus 4 is equal to x plus 4. Just by looking at it, we can see both sides have the exact same value. So even if we were to subtract 4 on both sides, I end up with x is equal to x. Any number I put in there is going to make this true. If I put 5, 5 is equal to 5. If I put 100, 100 is equal to 100. I can put any number and it's literally saying is equal to itself. So no matter what I put in for x, it's always going to be equal to itself. This has infinite solutions. It's infinite. Now, again, what if you had done the other way and let's say you wanted to move the x's? Okay. X plus 4 is equal to x plus 4. And if I subtract the x, cancels out on both sides, I still end up with 4 equals 4, which is a true statement. It is true. But this is also another sign that it is infinite. So if you end up with something, it's like a reflection of itself, x is equal to x or 4 is equal to 4, then we know that it is an infinite solution. So there you have it. In practice, as you're going through equations, as you work them out, think about the different ways you can solve them. It's either x is going to be equal to some number. So for example, x equals 3, that is one solution. If you get something that is absolutely not true, like 3 is equal to 10, we know that's true. That means there are no solutions. And if you get something where x is equal to x, then we have infinite solutions. Or if it ends up being a number is equal to a number itself, then that is also an infinite solution. So there you have it. We're going to stop there. Math Marbles. Let's write this down in our notes and practice out those equations and count and see. Notice how many solutions are possible for your equation.